Hey there, and welcome to another edition of Solve My Math Homework's Video Solutions. Today the problem that comes into us is a simple exponential equation, or solving an exponential equation. They look a little scary, they're really not, so let's do it. Okay, so it says here that we want to solve 9 to the 2x, right? So we have base of 9 raised to a power of 2x, and this expression is equal to 27 to the power x minus 1. We're obviously solving for x here. Okay, so I have said in the past, and maybe you've heard me say, if you have an unknown exponent, you have a logarithm. And in fact, a log is an unknown exponent. And most of the time, when you see a variable up in your exponent, you will need to use logs. The one time that you don't have to is if you see that your bases can be written as the same number. And that might not make sense. So let's bring it back a bit. If I could write these bases differently, if I could rewrite them with the same base. So if I could write 9 as, I don't know, 3 squared. Okay, well, all right then. Can I write 27 with a base of 3? Because then my bases would be the same. So yeah, I can. 3 cubed is 27. 3 times 3 is 9, times 3 again is 27. So I can avoid logs in this problem by rewriting the 9 and the 27 with the same base. So let's do it. So I'm going to rewrite the 9 as 3 squared. It's still being raised to the 2x power. Haven't really done anything but rewrite it. I'm going to rewrite 27 as 3 cubed, or 3 to the 3rd power. Still to the x minus 1 power. Again, I haven't done anything. Now I have to simplify this. I have to clean it up. But in order to do that, I have to remember my power property. Okay, my power property of exponents is really the power of a power. You may remember if you have a to the m power, and you raise that whole thing to another power, then you solve it by saying a to the m times n, right? And so let's think about this. If I had, I don't know, x cubed, and I had it squared, that means I just have two groups of two groups of 3x's. So I have 2 times 3, or x to the 6th. If you need to see it, I have two groups of basically this. I can't speak today. Sorry about that. Okay, so this is my power of a power rule. Okay, and I need to remember that for here. So when we do this, 3 to the 2, or 3 squared raised to the 2x is really 3 to the 2 times 2x. So 3 to the 4x. Okay, the only thing I want you to remember here is if you have an x minus 1 up here, you have to distribute the 3 to both the x and the negative 1. So you're going to have 3 to the 3x minus 3 power. Okay, and if you need to know why, 3 times x minus 1, you distribute the 3 to both terms within that parenthesis. Okay, so now I have the same base. Everything is good from here on out, trust me. So I know that I have the same base of 3. So 3 to the 4x is on the left side. 3 to the 3x minus 3 is on the right side. If I know these expressions are equal, well then 4x has to be equal to 3x minus 3. And I could solve that problem all day. 4x equals 3x minus 3. Okay, that's simple. That's a linear equation. It's got variables on both sides, but I can still handle it. We subtract 3x because inverse operations, we have a positive 3x, subtract 3x from both sides. So we have x equals negative 3. If you want to check it, okay, I know your teachers like you to check your work. 9 to the, let's see, 2 times negative 3, does that in fact equal 27 to the negative 3 minus 1? So does 9 to the negative 6th equal 27 to the negative 4th? Well, I'm going to have to put it into a calculator to tell you that. So when I do, I get 1, 2, 3, 4, 5 zeros, and 1882. And when I do 27 to the negative 4th, I in fact get 1, 2, 3, 4, 5 zeros, and a 1882. They do check. Okay? So I hope that helped. If you have questions, put them in the comments. Thank you so much for watching, and subscribe to our YouTube page, and I'll solve your homework problem next. Thanks.